Okay, so let's do on one example on mixed boundary value problem. Boundary value problem for a rectangle. Of course, Laplace equation. Okay, so here's the problem. PD is, as usual, the Laplace equation. X between 0 and A, and Y is between 0 and B. And the boundary conditions are ux0 equals 0, uxb equals 0 for x between 0 and A, and 0 u0y equals gy, and u sub x ay is hy 0yb. Sadece burada var. Yani o yüzden mixed oldu bu. Okay, so there is no derivative condition on these three sides, only on one side there is derivative condition. So let me draw a picture. So this is x equals 0, x equals a, and this is y equals b. So here we have Laplace equation, and here u is 0, right? Y is 0, x is anything between 0 and a, so u is 0. Here u is 0. On this side u is g, but on this side u sub x is equal to h. Okay, so let's see how we will solve this. Of course, you know, solution method is always the same, separation of variables. But before we divide this into two conditions, so two problems, sorry. Note that if u1 and u2 are the solutions of the problems below, then u, which is u1 plus u2, is a solution, or the solution of the original problem. So the first set of boundary conditions is this. And you, of course, they will satisfy the same Laplace equation, but the boundary conditions, we divide them into two parts. So this is as usual. This part is already 0, but the condition on the other side is divided into two. So this is like this: u1 sub x 0, sorry, not 0, ay equals 0. This is first equation, and the second equation is this same, of course, differential equation. I don't write it, but u2 satisfies this: x0 and xb are again 0, u2 0 y equals 0, but u2 sub x ay is just h of y. Okay, and again here x is between 0 and a, y is between 0 and b. Tamam mı? Yani standart üçkağıt. Şimdi nasıl çözeceğiz bunu? Let's first determine u1. So we just look for solution of this type u x y, x of x, y of y, right? And the equation u sub x x plus u sub y y equals 0 implies what? As usual, this is x sub x double prime y plus x y double prime is equal to 0. And from this, we have x double prime over x equals minus y double prime over y, and so on. And then, okay, now we have condition, 0 conditions here, right, for x. So let's say this is minus lambda. Çünkü, pardon, y şey olacak. Ha, şunu lambda, pardon. Bu y üzerine condition verecek değil mi? Y 0 olacak. Tamam. Okay, so from this we get x double prime minus xy equals 0 and y double prime plus lambda y equals 0. And this condition, all right, so let me switch to the other board. This conditions u1 x0 equals 0, u1 xa, no, xb, not a. xb equals 0. So this gives y of 0 is 0 and y of b equals 0. So we have these conditions and plus this differential equation. We know how to solve this. This lambda should be just n pi over L squared. And what is L? L is the length of this interval. So in our case, L is just B. So this is just n pi over B squared. N is 1, 2, 3, and so on. Positive numbers. So let's just decorate it with N. And then the corresponding solution for this lambda is just yn, and it is just sine n pi y, right? Because our variable is y over L. So it is just sine n pi y over b. So this is y. And what about xn? Well, for xn, we have this equation. And lambda is just this number. So we just plug it here. Characteristic equation is r squared minus lambda n equals 0. So r is just n pi over b squared, r squared. Therefore, r is just plus minus n pi over b. All right, so we have two solutions. Y n, no, not y n, I'm sorry, x n, right? We already determined y n. X n of x is just, let's say a n e to the power n pi b over x plus b and e to the power minus n pi b over x. All right. We have this homogeneous condition u1 sub x equals 0. Well, u1 is x times y, therefore u1 sub x is just x prime times y. And this gadget is 0 for nerede sıfırdı? A virgül y'de. A virgül y'de 0. O da ne demek? X prime a minus y equals 0. Since I don't want 0 solution here, it's better this gadget is just 0. So x prime should be 0 when I plug x equals 0. So from this, we just x prime x is just what? N pi b a n. Şurada isterseniz 0 da koyalım. Let's plug 0 also. You know, let's perform two operations at once. Efendim? A koyacağız. Evet. A koyunca an e üzeri n pi a over b plus bn ya da minus, right? Minus bn n pi over b, bn e to the power minus n pi a over b. So this is equal to 0. From this, we get what? We get, okay. Bn is just, so if I just, you know, this is equal to 0, right? So this means these are equal to each other, right? So Bn is just, these are gone. Bn is just an times e to the power 2 n pi b over a. So Bn is just e to the power 2 n pi a over b, an. Okay. O zaman x'ini tekrar yazalım. So xn of x an parenthesis, hatta an e to the power n pi b over, bir dakika. Nasıl? Şurada x de var. Tamam, bir saniye. Neyse yazalım şöyle. N pi x over b plus bn is just this, e to the power 2 n pi a over b e to the power minus n pi x over b. Efendim? An'i de var. Evet. An'i de var. Şimdi an ve şey parantezini alırsak şunun yarısı, yani e üzeri n pi a over b, an parantezini alırsak burada ne kalacak? E to the power n pi over b x minus a. Burada da n pi b x minus a with a minus sign. Yani aslında bu kosinüs hyperbolik oluyor, değil mi? Bir de 2 koyarsak. So this is just 2 times e to the power n pi a over b a n cosine hyperbolic x minus a. Yok, pardon. N pi over b x minus a. Tamam mı? O halde şey ne oldu? un xy. So xn of xy times yn of y. Right? This is xn of x times yn of y. So it is just yn neydi? Ha, şuydu. Xn de bu. Şöyle yazalım. 2 tane e üzeri 2 pi a over b an cosine hyperbolik, efendim? Ha, 2 buradaydı. N. Allah'tan bu dersi almıyordum. Değil mi? Öğrenciyken böyle değildim ama. Okey. Bu ne oldu? Cosine hyperbolik x minus a. Burada da sine n pi y over b. Okay. So uxy is just some of these. Of course, it has these coefficients to be determined in it. And how we determine this? We will use the last condition. G sub y, G of y is just u1 0 y. u1 0 y. So I plug 0 for x. When I plug 0 for x, this is just 0. So I get, okay, 2 times an e to the power n pi a over b cosine hyperbolic n pi minus a, but cosine hyperbolic is an, I mean, if you plug minus a, nothing changes in cosine because hyperbolic, değil mi? Burada yani bunu eksiyle çarparsanız bunu elde ediyorsunuz zaten. So this is just a over b and then sine n pi y over b. So from this we see that this coefficient here is equal to what? This coefficient here just 2 over L. L is just B here. 2 over B. 0 to B. G of Y sine n pi y over B dy. So we just compute whatever that thing is. And then mesela gy yerine şey versek, değil mi? Gy'yi şöyle seçecek. Diyelim ki kolay bir şey olsun. sinüs değil mi? 3 pi bölü b g seçsek değil mi? Bu ne olacak? Bu hep 0 olacak. Şey hariç ne eşittir? 3 hariç. E, yani o zaman da 1 olacak. Değil mi? Nereyi sileyim? Burayı silebiliriz. So u1 xy which was this infinite sum, but there is only the term for n equals 3. N equals 3'de de ne olacak? İki tane A3 E üzeri 3 pi değil mi? A bölü B kosinüs o u'yu yazacağım. Tamam, A bölü B kosinüs hiperbolik 3 pi bölü B x eksi A. Burada da sinüs n pi bölü y b. N eşittir 3 ama değil mi? Şu. Ve ben ne biliyorum? Şu ifade yok. Ne biliyoruz? 2 A3 E üzeri şu ifade 3 pi A bölü B kosinüs hiperbolik 3 pi bölü B A eşittir 1. Değil mi? Bunu biliyorum. Dolayısıyla da A3 yani şurası zaten 1 bölü bu. Yani o zaman U1 xy eşittir 1 bölü değil mi? Şu ifade yerine 1 bölü cosine hyperbolic 3 pi a over b and then cosine hyperbolic 3 pi over b x minus a sine 3 pi b over y. Okay. So this is U1. What about U2? Well, for U2, we have the same equation. Let me rewrite. Okay. Yani aynı şeyi yapacağız. Şöyle diyeyim. U2 is just x of x, y of y again. And then I have x double prime over x, y minus y double prime over y. And the conditions are u2 x0, u2 xb are again 0. So bunu gene lambda alacağız o zaman. Çünkü şunu kullanacağım. Bu daha kolay olacak ama u2 0 y is 0 and u2 x ay equals h of y. Peki şuradan ne elde edeceğim? So these conditions will give me as usual y of 0 and y of b are both equal to 0. And from this we get x double prime minus x lambda x is 0 and y double prime plus lambda y equals 0. And this equation together with this boundary conditions, we have lambda n is again n pi over b squared, right? The same stuff. And yn is just sine n pi y over b. All right. Yes. And then we have U1'i buraya yazdık zaten. Evet, evet, evet. Yani hepsini yapmamıza gerek yoktu. Tamam. Neyse yani zaten şey. Pardon, ben kamerayı çevirmemişim. Okay, so for this is U1, and for this coefficient, I know from that integral condition that this product is 0. So this is just 1 over cosine, and we just wrote it here. So we computed U1. For U2, we write down the same equations and so on, the same boundary conditions. Here gives me lambda n and yn. And for xn, again, we have the same stuff. Xn of x, right? Xn of x is again the same thing. E to the power. Nerede yazmıştık ekseni? Sildik mi? Okay. An e üzeri n pi x over b plus bn e to the power minus n pi x over b. Yok. Şimdi boundary condition, for this one, boundary conditions are different. This one, so u sub 2, 0, y equals 0. This gives me x of 0 is 0. So when I plug 0 for x, I should get 0. And when I plug 0 for x, I get just an plus bn equals 0. Okay, so bn is just minus an, therefore xn of x is just an parentheses, and then this is just e to the power n pi x over b minus e to the power minus n pi x over b. This is just 2an, this time sine hyperbolic n pi x over b. Okay. So what is un? xy, x1 of xy and y1 of okay. So sine hyperbolic n pi x over b and sine n pi y over b. Okay. And then we have the last condition. So, okay, u xy is just the infinite sum, u and xy, and from 1 to infinity. And the condition, boundary condition was neydi? U2 yok. U2 sub x. AY equals h of y. Okay. Yani bir daha türev alacağız. Neyse, sorun değil. Okay, so I need to take derivative of this. This is ne demiştik? H of y. When I take derivative, I get what? So I take derivative with respect to x. This will be cosine hyperbolic, and this coefficient will go in front. So 2 n pi over b cosine hyperbolic n pi x over b, and x is just a. Okay, and sine n pi y over b. So from this, we see that this whole thing is equal to 1 over L integral 0 to L h of y sine n pi y over b dy. 2 over L'di. Özür dilerim. Neyse, yani buradan da anladık. HY'da mesela şey olsaydı sin n sin y pi over b olsaydı bu ne olurdu? A1 dışındaki hepsi 0 olacaktı, değil mi? N equals 1 here. So all these coefficients would be 0 except the first one. So U2x y would be just sadece A1 olacak. Yani 2 tane A1 sinüs hyperbolik pi x over b sine pi y over b. A1'de nedir? Efendim? Ha, yani A1 1 mi oluyor? Ha, bu ifade 1 oluyor. O zaman A1 nedir? A1 bu 1 olduğuna göre 1 bölü B bölü pi, değil mi? A1'i bulmak istiyorum. B bölü pi ne eşittir 1? Kosinüs hyperbolik pi a over b. 2. Nerede 2 var? Burada mı? Burada. Tamam. Neyse, bunu da alıp burada yerine koyacağız. Evet, çok da sadeleşme olmayacak. Ondan sonra da ikisini topluyoruz. U1 ile U2, o kadar. Tamam mı? Okey. Tamam. Şimdi bir de annulus için problem var ama onu aslında biz half annulus'u yapmıştık. Sonra disk var, onu da yaptık. Tam annulus'u yapmadık. Yani ona isterseniz notlardan bakın. Hani ona benzer şeyler yaptık. Orada so for the whole annulus, for this region, we have only two boundary conditions. But since this is a whole circle, there is also a compatibility condition coming from neydi o işte kosinüs 2p, so we want the function to be continuous on the boundary, therefore sum of the coefficients would be 0. We had the same problem when we were studying the problem for the disk. Okay, but this time r being 0 will cause no problem, because r is not 0 on this region. So this is slightly different than the problem we had for the disk. It is in the notes. I don't want to spend more time on this. Let's give break. After the break, I'll talk about a little bit Fourier transform. Okay, so it is a different subject.